All right, so we're going to talk about molarity. We're going to talk about molarity as a concentration. So molarity is a measurement of number of moles of solute in liters of solvent. So as a solution concentration, count the number of moles, divide by the liters of solution. Moles divided by liters is molarity. So if you think about this, our molarity triangle, if we're going to calculate molarity, we cover that up, take moles divided by liters. If we're calculating the number of moles present, we take the molarity of the concentration times the liters of solution. Molarity times liters will give us moles. If we're looking for the volume, we cover up liters, we take the number of moles divided by the molarity. That'll give us the volume. So cover up what you're looking for, treat the rest algebraically. That's how you do this. So, one of the questions on the review was, what is the molarity of a solution that has 71 grams of HCl, hydrochloric acid, mixed in solution in a 1,000 milliliter volumetric flask? Well, we have 71 grams of HCl equals how many moles? That's really the question. Because if we have grams, we would convert that to moles. That'll put it here, divided by the liters of solution. There's the bell. Liters of solution is right here, 1,000 milliliters in the volumetric flask. So there's 1,000 milliliters, which is equal to 1 liter. So we just convert grams to moles. And remember our gram-mole conversion. Grams, moles, molar mass. So we're looking for moles. We take the number of grams divided by the molar mass. That gives us moles. This moles then goes in here, divided by liters. And in this case, it's 1,000 milliliters. So 1,000 milliliters is equal to 1 liter. So that's going to be 1. So if we can find how many moles we have, that many moles divided by that many by 1 liter is the molarity. Molarity is moles per liter. So let's focus on this. Take 71 grams divided by the molar mass of HCl. What's the molar mass of HCl? Well, H has a molar mass of 1 gram per mole. And chlorine has a molar mass of 35.45 grams per mole. So that has a total of 36.45 grams per mole. And that's hydrochloric acid, HCl. 36.45 grams per mole. So we take 71 grams divided by 36.45. 71 grams divided by 36.45 grams per mole. That grams cancels with grams, and 1 over mole brings moles to the top. So we're in moles. So 71 over 36.45 is approximately 2 moles. So that means we have 2 moles. Put that here. 2 moles. If we want to calculate molarity, we take the number of moles. 2 moles. Divided by the number of liters, right? Covering up molarity. Moles divided by liters. 1 liter. So the molarity of this case would be 2 molar. Okay? So we have a 2 molar solution in this question. So what happens if we were asking the question about how many grams of sodium hydroxide, for example, would go in a different volumetric flask? Well, I'm going to move the camera up here so we can take a look at our volumetric flasks. Well, we have 3 volumetric flasks, a 250 milliliter volumetric flask, a 500 milliliter, and a 1,000 milliliter. In terms of liters, this is 0.250 liters, and 500 is equal to 0.500 liters, and 1,000 is equal to 1 liter. Okay? So what we do is we calculate how many moles of sodium hydroxide, so NaOH. So we take the grams of NaOH divided by the molar mass of NaOH, and that'll give us the number of moles. The number of moles of NaOH divided by the liters, depending on the size of the container, moles per liter is molarity. Molarity is moles per liter. So calculate your moles here. Figure out what your liters are based on the volumetric class. Put that here. Moles divided by liters is molarity. There you go.